Welcome, hope you are doing well. My name is Kunal Kalwankar and my topic name is Abstractive Summarization based on topic tuned models. I have been guided and helped by thesis supervisor Dr. Diksha Malhotra for this research. Let us begin with an introduction to the topic of document summarization. Document summarization is the creation of a concise set of sentences from the whole document. It conveys the complete meaning of a document. The summary is less than half the size of document length and preferably much smaller. Further, the document summarization can be classified into many types based on its functionality. Uh, Let us start with abstractive summarization. Abstractive summarization is a type of natural language generation which creates summaries from articles which are very close to human summaries. As opposed to extractive summarization, which picks up sentences as it is from the document and arranges the summary. To the left, you can see the techniques which are in scope for our research. We are going to use abstractive summarization with a short document input and a single document input. What is out of scope is the use of extractive summarization or the use of long documents as inputs or even use of multi-documents. We can start with a review of techniques that have been already used for abstractive and extractive summarization. For extractive summarization, which goes back as much as 2002, we have fuzzy logic, rule-based rankings, and hidden Markov models-based techniques, which are not necessarily data-driven and are conventional techniques. We also have a lot of deep learning-based techniques for extractive summarization, such as based on encoders or based on central values of the clusters, RNN-based and based on state-of-the-art models like BERT. So moving on to our focus area, which is abstractive summarization. The journey here starts with RNN encoder-decoder networks. Now the RNN encoder-decoder networks can have a lot of variants when they are using different cells like LSTM and GRU as their building blocks. This can be then followed by an addition of attention layer to the same network. We also have bidirectional encoder-decoder networks which work on the same concept, but instead of training the models from a single direction, there is an additional set of sequential cells which are trained on a different direction of the same text. So all these models discussed before work on sequential inputs, but the transformers, which is the focus area of our study, actually work in a parallel way. These were introduced by Vaswani et al. In 2017. Uh, the transformers are then modified into a lot of state-of-the-art models. Uh, One of them can be pointer generator network, which introduces a pointer which can help in copying the input sentences or input words directly to the output. Then we have CNN based techniques which extract features using a convolutional neural network. This can be followed by BERT-sum. BERT-sum also uses BERT embeddings to create rankings of words, phrases, and sentences which are used for abstractive summarization. We have Pegasus, which is also a state-of-art model. Pegasus basically has target summaries which have masked outcomes. So words and sentences are masked, and then the model is trained to predict the masked sentence. Finally, we have BART, which is a combination of GPT-2, which incorporates sequential learning, and BERT, which incorporates parallel learning. Moving on to the problems mentioned in literature. In abstractive summarization, we have factually incorrect details which seep into summaries like name of places and countries which are not actually in the article. The summaries produced using abstractive summarization do have a lot of repetitive inputs in the form of words or even in the form of n-grams. This can be followed by another issue, which is that the output sometimes tends to be extractive in nature. This has been seen in the case of pointer generator networks. And last but not the least, these algorithms are very heavy, which is the reason why open source researchers find it difficult to implement them from scratch. Before moving on to the problem statement, it is important to understand what exactly is a named entity. A named entity is a real-world object that's assigned a name. For example, it can be name of a building, a name of a country, or even a number. The current state-of-art models have difficulty achieving specific context since they are extremely generalized. This leads to our problem, that is the creation of false entities in the summaries. So, false entities or false named entities seep into the summaries which are not actually present in the article. This problem has been mentioned and discussed in paper by Nan et al., and our research seeks to find a solution. Based on the problem statement that we discussed, let us try to establish research questions. So, does the novel approach which we are trying to propose help in reduction of false entities, which is a known problem in abstractive summarization? Could we improve on the existing hard mathematical benchmarks for text summarization, which use metrics like root scores? Do the number of model parameters contribute to creation of false entities? And finally, a generalized question, could this proposed approach provide a tangible assistance to selecting or moderating articles? So let's discuss the proposed methodology, which will try to address the questions before. As you can see, here we have given an example of data split into three topics: business, sport, and tech. Each of these topic is a subset of the data set. A T5 model is tuned based on each of these topics. So each topic corresponds to a differently tuned T5 model. The intention behind this is to give us very specific and a tight context uh, to each of these models, uh, and we expect that false entities would actually decrease because the model has a good context of what words it has to predict and what words it should avoid. Based on the previously discussed methodology, we split the data into topics using two techniques. The first one is based on Auto NLP. It is a pre-trained model which is available in Hugging Face. Uh, it splits the data or the input articles into five separate topics, which range from entertainment, politics, sports, etc. The benefit of this method is that there is no overhead time involved for training these topics, and we can directly go to train the separate models. The second technique used is creation of topics using k-means. Here, we create a TF-IDF vector from the input text, which gives as much as 2 million columns because there are 2 million words. Now to solve this problem, we use singular value decomposition and condense these 2 million vectors into 1000 most important vectors. So we pick up the most important 1000 vectors, and on top of that we create a k-means cluster. So we have two variants of 3 and 5 topics each. Results of each have been discussed in the further slides. The dataset used for this experiment is the CNN Daily Mail dataset, which is openly available on the internet. We have three columns corresponding to this dataset, which is the article ID, article text, and highlights. The article ID has unique identifier for each article. There are 300k such articles, and we have taken a random subset of 25,000 articles. This is followed by the article text. The article text is a corpus of articles which range from 150 to 5000 words. And this is followed by highlights. Highlights are handwritten summaries by journalists. Uh, there is a severe imbalance in the data, as can be seen in the left bottom table. We have high values for entertainment but low data points for tech. This has been solved using the subsetting itself. So we have taken 5000 article each from each of the topic. That solves the problem of imbalance in the data. The transformers are at the heart of our research. we have used a T5 implementation of the transformer. A transformer enjoys great benefit as compared to sequential recurrent neural networks because it processes the input data in a parallel way, which saves a lot of time. Coming to the components used in a transformer, we have the encoder-decoder network. So the encoder will compress the information and send it to the decoder, which then generates a language based on the input data or the thought vector passed from the encoder. Then we have the multi-head attention concept. So multi-head attention is based on the self-attention mechanism. The self-attention mechanism creates a relationship between words of a input sequence with other words in the same input sequence. So essentially, what multi-head attention does is it expands on the same concept and parallelizes the activity of self-attention. Then we can discuss about positional embeddings. The positional embeddings are cosine and sine functions which describe the exact position of a token within the input token sequence. The T5 summarization model has been trained on four downstream tasks. In order to use any of the functionality, we have to add a specific suffix. For example, in order to summarize, we have to add a suffix called summarize, or if we want to translate it from make it translate from English to German, we add that suffix, and the T5 model will give us the respective outcome. Uh, the T5 model has been pre-trained on a huge amount of data, and its architecture is generic and similar to that of transformers. Uh, Other than the transformers architecture, they make use of masked inputs and corrupted inputs in order to train the model. So these are the hyperparameters we have used for training and fine-tuning the T5 model. For each topic, we had 3150 articles for training, 1100 for validation, and 500 for test. Uh, Combining all the five topics, we have 2500 test articles, which help us in getting all the metrics. If we move on to the specific hyperparameters, we have used 4 as a number of beams, which is the uh, number of words or tokens the model checks in advance and uh, predicts. The minimum length which is allowed is 30 tokens. We have used the early stopping option as true. Uh, the maximum input length is 512 tokens, which is a limitation if we are using a short document summarization technique. Uh, the no repeat n-gram size is 2, which means that any n-gram which is of the size of 2 cannot repeat within the outcome summary, which helps us a lot in solving one of the problems of abstractive summarization. The maximum length of summary is 150. We have tried three epochs, 3, 5, and 7. However, only 3 has worked for us. 5 and 7 do some overfitting. The batch size used is 8 throughout all the experiments. So the reason why a lot of hyperparameter tuning is not done is because our focus was mainly on uh, using multiple techniques instead of using a single technique and tuning the hyperparameters. For this research, we have mainly used the following resources. The software used was Python and the Python library scikit-learn. ML APIs used were PyTorch and AutoNLP. The platforms used for training were Kaggle and Colab for different applications within the research. And the hardware used was P100 GPU, which was accessed through Kaggle. Now going through the results of experiments we conducted on the T5 base model, we can see that the Rouge metrics were actually the best for T5 model that was tuned without using any topics. Uh, so there cannot be seen any considerable improvement in the Rouge metrics. Uh, Coming to entity hallucination with respect to golden summary. So we have defined the entity hallucination as the number of false entities which are there in the summary but which are not there in the text which is being compared to. So if we compare it to golden summary, the least which we can see is in the auto NLP based method, which is 81.7%. Uh, if we see entity hallucination compared to actual article, which is very less for the summaries generated, we can see that the two methods which we used, the auto NLP based method and the k-means 3 clusters, k-means 5 clusters based methods, are actually helping us reduce the false entities. So the least false entities are generated by k-means clusters, which are 5, and so we have technically trained 5 models and combined the results of these models. So that is actually giving us good results. So method 2 shows best results when it comes to hallucination with respect to article, and there is no considerable effect on Rouge metrics. Coming to T5 small model, which is a smaller model than T5 base, uh, which has 60 million parameters, we can see that the Rouge metrics give us mixed results. For some of them, the topic split is not effective. For some of them, it is. However, if we come to entity hallucination compared to actual article, we see that the results are consistent. That the k-means methods are actually helping us in reducing the entity hallucination to a great extent. So method 2, which is based on k-means, shows great results for reducing the hallucination with respect to the article. The Rouge metrics are almost the same, we can say, or not much improving. Uh, Another observation that can be made is that T5 small performs better than T5 base in avoiding entity hallucination. So this answers one of our research questions, which we will discuss further in detail. So I would like to recall the previous research questions that we discussed, and uh, corresponding to them, we can discuss the conclusion and observations here. Both methods were able to reduce the overall creation of false entities, the auto NLP as well as the k-means method. This technique does not help in improving the root score and at best maintains the same. But at the same time, we also have to understand that root scores are not the only mathematical metric that a summary should be judged with. We also have to keep in mind that false entities should not be generated. More complex the model, more are the chances to create false entities. This can be seen in our results as well, where T5 base model creates slightly more false entities than T5 small model. This might be due to increase in variance due to model complexity. The final one is the whether we can use this for uh, moderating articles. The answer is yes. However, deployment requires a different process than the one used for testing the research questions. I would like to conclude this by discussing the future scope of this study. There can be improved focus on hyperparameter tuning using the same techniques. We can do a grid search, and probably this can bear different or better results. Additionally, more clustering techniques need to be experimented upon for better results. So instead of k-means, we could use some other popularly known statistical techniques. The same methods need to be checked on other state-of-art models. So instead of just T5, we could experiment on other models like BART or Pegasus using the same technique of splitting the topics and the models. Thanks a lot for watching my presentation.